Okay, so in the last video we were learning how to convert from degree measurement to radian measurements. And if you went through the process in class of filling in this general circle, which you'll do at some point in class, I'm not sure when you're watching this, but you'll get a good sense of what degree measurements equate to a certain radian measurement. And so I would suggest to you that initially um, you should know these at a minimum. The first quadrant worth of angles, so 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and their radian complements. Of course, you should know 180 is the same as pi, and then 270 is the same thing as 3 pi over 2, and then of course finally 360 degrees is 2 pi. Now that gives us all of our quadrant 1 measurements and what we call our quadrantal measurements, our angles that are on the axis, the x-axis and the y-axis, and so you'll have a pretty good sense of how the quadrants are broken up. So if you ever see a range of values either given in degree measurement or a range of values given in radian measurements, you will know what quadrant those angles fall into. And in a lot of problems that you work in trigonometry, understanding what quadrant it falls into and what range of degrees or radians fall into that quadrant is really, really important. So but at first off, you should get to know these at a minimum. And so of course we've taken these common measurements and we've shown you, I've kind of created a chart here that shows you kind of basically like a family of measurements that go with them. So this is really good to know and to understand. And so sometimes you have a problem like sample problem number 3 where it asks us to evaluate the trig function, and of course in this case the angle. And so if we're evaluating the sine of an angle, that angle is going to equal the opposite over the hypotenuse as if we were in a right triangle. Well, in this case we need to know what pi over 6 is as an angle, and if you don't know immediately the sine and cosine and tangent of pi over 6, you can simply recreate that in a degree measurement, which is 30 degrees. And if you recall, you know that that's a common measurement that you should be familiar with. So sine of 30 degrees is equal to 1/2. And so you would do that as a quick adjustment of converting back and forth from radian measure to degree measure. Now, if you don't remember what the sine of 30 degrees is, if you go back to the first lesson in this unit, you actually filled in a table of values for the sine, cosine, and tangent of common angles like 30, 60, and 45 degrees. And this is also something that you should have done in geometry as well. So go ahead and try part B, cosine of pi over 4, and see if you can come up with that part right there. Okay, hopefully you remembered that cosine of, pi over 4 is the same thing as cosine of 45 degrees. And if you look back at your chart, or if you recreated the triangle, whichever method you did to come up with this, you know that we have the square root of 2 over 2. And be sure not to put the radical in the denominator. So if you had 1 over the square root of 2, you would need to rationalize the denominator. Now, sometimes we'll be given angle measures in quadrants 2 through 4. So we won't have a 30-degree angle or a 45-degree angle or something of that nature. So if we were asked to find, say, the sine of 150 degrees, well, we may not be able to remember all of the degree measurements in which match up with that table. However, since we have a family relationship with 30 degrees, 60 degrees, and 45 degree angles, we can reference everything back to those particular angle types. And so if we are working in quadrant 2, quadrant 3, or quadrant 4, and we're working with an angle measure, we can create what's called a reference angle. And you can see here in each quadrant we're giving you a range of values for the quadrant. it tells you how to actually come up with the given angle measure, either in degrees or in radians, and then you can reference everything back to the reference angle. So before we do a problem like that in the next lesson, what you'll need to do is get comfortable actually coming up with the reference angle. So definitely use these three pictures, visual references, to help you out with this for sample problem number 4. Go ahead and try to find the given reference angle for each of these. Okay, what I find is the best way to start in doing this, and each of you will be different. Some of y'all will prefer the mathematical method, some of you will prefer the visual method, and of course I tend to still be a visual learner, so I tend to use visual examples, and I will do the mathematical as well. So what happens here is this. We have a 320 degrees, and so if you're familiar with 320 degrees, you know that wraps around somewhere in here, in the fourth quadrant. So it's not exact, but that's a good approximation. Now what that allows me to do is to know what my reference angle is going to be. And if I'm in the fourth quadrant, my reference angle is going to be from the x-axis down to the 320 degree angle. And so what I'll want to do is take 360 degrees, subtract my given angle, and what will be remaining is 40 degrees, and that's going to be my reference angle. So we call our reference angles the original angle is considered theta, so our reference angle will be theta prime. So you'll see it written like this: theta prime equals 40 degrees. And so that's our reference angle for that particular problem. Okay, let's take a look at a reference angle when given radian measures. And then this is a little different as well because we were given a negative measurement. So the first thing we need to do is we need to come up with, where does negative 5 pi over 6 fall? Well, we can subtract that from 2 pi, and what we can figure out is if we subtract that from 2 pi, it's coterminal with 7 pi over 6. So that angle is going to come around to about right there. So this is 7 pi over 6, which is our coterminal part of negative 5 pi over 6. And so that allows us to come up with our terminal side. And of course we're starting all of this from our initial standard position. Now what we're looking for is the reference angle of this. And so we can see here we're in quadrant 3. The reference angle is actually going to come from the x-axis here. And so that's what we would call our theta prime. And so we know that we're dealing with pi there in that particular part right there. So we would want to subtract pi from the 7 pi over 6, and when we do that we learn that our reference angle is simply pi over 6. So there's a couple examples of how to find reference angles. Now this will be an extremely important skill as we move into other types of problems in later lessons. So make sure you have a good understanding of reference angles.